Hi, my name is Daniel Pluta from the Netherlands. Welcome to this video presentation of the Gen AI Intensive Course 2025 Q1 Capstone Project. The topic of my project is Agentic Regulatory Retrieval Augmented Generation, or RAG, where traditional RAG will be compared to Knowledge Graph RAG. Here you see the installation of necessary Python packages. In the meantime, I will tell you about my use case. Querying on regulatory documents by using an AI assistant can be very useful to legal and compliance teams to save time and money. A good quality response is crucial. Traditional RAG does often a poor performance. Knowledge RAG can help to increase the quality of the response. For parsing documents, the open source Docling package is used. The processing progress of 3 regulatory PDF documents is shown here on the screen. After parsing the input documents, the Google Gemini API key is initiated. This part shows traditional RAG. After initiating the API key, the parsed documents are chunked, vector embeddings are created, and stored in a ChromaDB database. Chunking is ready, and there are 235 documents stored in the vector database. The created collection in ChromaDB can be queried. For demonstration purposes, 3 specific chunks are shown. Also, the number of elements within the vector database are counted. For the first chunk, the vector embeddings are displayed. The notebook also shows a vector similarity search regarding a query about the EU AI Act. The traditional RAG part concludes with a RAG agent that has been built with Pydantic AI. Here you can see the result of the traditional RAG summary. Although a very detailed summary in 1,000 words is requested, the response result is for this specific request quite short. The next part of this project is the implementation of Knowledge Graph RAG hybrid search with open source package LiteRAG. LiteRAG supports a hybrid search of vector embeddings and knowledge graph embeddings. LiteRAG is installing necessary Python packages. Also, LiteRAG provides the possibility to perform a similarity search. Here, the option to perform a hybrid search is chosen. LiteRAG is taking care of chunking. Also, both the vector embeddings as well as the knowledge graph and knowledge graph embeddings are created. Depending on the size of the unstructured PDF documents, it can take a while before the knowledge graph is created. The LiteRAG's built-in local storage functionality is used for this project. The result of a hybrid similarity search for a document regarding ESG ratings in the Dutch language is shown. Great! This shows a huge difference as opposed to traditional RAG. The next step is creating an interactive knowledge graph visualization. Nice. The interactive knowledge graph visualization creation is completed. Zooming and show the details of the knowledge graph. The last step is the creation of an Agentic RAC agent with Pydantic AI for Knowledge Graph RAC. Here you can see the result for the same question as in traditional RAC. Please provide a very detailed summary of the EU AI Act in 1,000 words. The result is a very detailed summary with a high rate of accuracy when compared to the original unstructured PDF document. To conclude the project, the conclusion compares the answers retrieved by the Agentic RAC based on traditional RAC versus Knowledge Graph RAC. Please note that another run of the agents might result in another version due to the non-deterministic nature of large language models. You have reached the end of this video demonstration. Thank you for your attention.